Hey, this is Digital by Computing. We're going to go through different types of business IT infrastructure. So, you may already work in a company that has a large IT infrastructure or a smaller IT infrastructure, or you may just be inquiring about, well, I'm at home, I've got a computer at home, I connect to the internet, but what about a big business? What sort of infrastructure, what sort of servers and network equipment, what do these companies have to get all this stuff up and running? You know, when I'm surfing a website, that's going off onto the cloud somewhere. Where's it actually going? It's going somewhere. So you may just be inquiring about what is involved in IT infrastructure. You may yourself be in an IT department, like you may be working in IT. You could be doing some stuff like help desk, desktop support, and you maybe want to inquire about, well, let's look at moving into like a level 3 infrastructure type of position, and what opportunities are available for you there and what sort of infrastructure is available. So let's dive into it now. So most companies will have routers. You may have already heard of routers. You may actually have a router at home. Actually, you probably do have a router at home. If you connect to the internet, you've got a form of a router. A router is essentially a device that lets you connect one network to another network. Right? So in your case, say if you're at home, connecting your home network out onto the internet, into another network, essentially. So a lot of businesses will have routers, obviously for doing that, for connecting from the network out to the internet, but also routers to route traffic within your own network, within a business network. So you've got these things called subnets, you've got different IP ranges, you've got what's called DMZ zones. So these are zones where you've got computers and servers that are accessible out to the internet, and they're more secure, and you don't want to get anything out from the internet accessing anything else other than your DMZ. So if you've got things like file servers and database servers and things like that running on a IT network, you don't want those accessible from the internet. So you've got routers in place to route traffic and essentially let you know, okay, well, when something accesses this router, move all the traffic to this other router and to this different part of the network. So in a nutshell, routers let you connect networks together. You've also got things called firewalls. So generally you will have a firewall in your network, and this is what controls traffic coming in and out. All right? If you don't have a firewall on your network, then essentially anything can come into your network and anything can go out to the network. Okay? You could have something like a server on your network that has internet access out to the network, or a server in your network and the internet, somebody who's, let's say, trying to hack in, can just go and access your server really with not too much trouble if they know what they're doing, if they know what ports to access, for example. So having firewalls in place lets you stop traffic coming in and out. So firewalls can be physical devices, similar to routers. Routers are physical devices. Firewalls can be physical devices. They can also be virtual. So you can have things like physical routers. You can also have physical firewalls, such as you've got your Cisco ASA firewalls. You've also got virtual firewalls, which essentially run on servers, something like a HA proxy or something like that, which lets you mimic the hardware of a firewall, right? And you can block things like ports, you can block IPs, you can allow certain traffic, certain IP ranges, you can do any rules, you can block rules, you can do a whole bunch of stuff with firewalls to allow and deny access to certain services on a network. You've also got what is called a switch. So what you'll find is a lot of home routers, right? You may find on the back has some network points. Yeah, you may have one point that has, that goes out to your street for your phone line or something like that. But then you may have 4 ports on it as well. That is essentially a switch that is built into a router. So it's a router switch modem, for example, what you may have at home. In a corporate sense, you've got much larger scale switches. So you may have longer switches. There's companies such as HP, Cisco, Juniper. There's others that provide switches, and you're essentially patching ports into a switch to be able to allow multiple connections to be able to access services on your network. Okay, so let's say you've got, 200 computers on your network, How do you get them to talk to each other? How do you get them to talk to the servers? How do you get them to talk to the routers? How do you get them to talk to the firewalls, to talk to the websites? All this sort of stuff, it all goes via switches, all right? These switches, as I said, you've got, generally in an IT infrastructure, you've got what would be called a core switch, which would be switches at the top of your level, of your layer, right? And then out of that, you have your extender switches, something like fabric extender switches, where you have a switch at the top and there's switches down the bottom that connect into your core switch, for example. And then essentially every device on your network, your printers, your servers, your desktops, your laptops, other bits and pieces, all connect into these switches to allow communication between them all. The switches, you can go and configure things like VLANs, you can block, or you can create certain VLANs to essentially have, let's say VLAN 1, have it on a particular IP range, and then on the same switch you can have VLAN 2 on a different IP range, and have them all on the same switch, connected to the same switch but on different VLANs, and they won't be able to communicate with each other. Right? And in that case, you'll need a router in place to sort of route traffic between them. But you can do a lot of cool stuff with switches, allow traffic through, let them communicate with each other via what's called trunk ports. You can run, from one switch to another switch, you can run cables so that you can make them appear logically as one big switch. That's it. That is essentially what a switch is. So we looked at routers, firewalls, and switches so far. On top of that, a lot of companies may have what are called patch panels. Now, a patch panel will only really be used if you have, let's say you've got a big company, right? A big office space, and you maybe want to route cables from one end to the other. You may have different floors, etc., etc. You may generally have one server room or one comms cabinet, communications cabinet in a business, for example, with all your switches plugged into there. But then on the other side, on the other side of your company or upstairs, you've got computers, you've got servers, you've got something. How do you connect them? All right, you can route a cable through, but what's also helpful is you can have smaller comms cabinets scattered throughout your business, throughout your actual company, which are called patch panels. And essentially all that's going to do is you would run a cable into a patch panel, let's say all the way over here, and then back at the patch panel, you have a cable that comes out and runs into a switch, which is down this end, all right? So you're essentially extending the length of cables, you're keeping all your cables nice and neat. So rather than running cables from here, all together to the switches, you have sort of spots between them, which would be a patch panel. You'd have all your devices on this, plugged into your patch panel, and then out of that, go into your switch, for example. So firewalls are what allow you to block and open traffic out to the internet and within your services on your in your infrastructure environment. So what do I mean? You've got a server sitting down here, you've got the internet sitting out here. You don't want all of the ports, you don't want anybody out on the internet being able to go in and access this server. This server's got some information, right? It's got some critical information. You don't want this out on the internet. You also don't want this server perhaps to access the internet, right? Because you may be able to infect it with viruses or things like that. So what you can do is you can put firewalls in between those layers. So say from your router to your server down here, in the middle, you've got a firewall. And a firewall controls your traffic going between, back and forth, right? And controls things like your IP addresses, your ports. It can allow and deny access to certain things. So let's say, for example, you've got port 80. Port 80 is what's used for your HTTPS, your HTTP traffic, sorry. HTTPS would be port 443, but let's say port 80, you've got your traffic that goes, port 80 would be used for your web browser, right? You open up a web browser, Internet Explorer or Google Chrome or something, you access HTTP that is using port 80, okay? So what you may want to do is if I've got a server that has some critical information and I don't want this server to be accessible and to access the internet, you can block on the firewall port 80 from this server. So what's going to happen is this server is now going to go, all right, I want to access the internet, so I'm going to open up a web browser, go to http://google.com, whatever, and it's going to go port 80, it's going to traffic through port 80, it's going to hit the firewall, it's going to say, the firewall's going to say, sorry, this traffic is blocked. You cannot, this source, this IP address of this server cannot access the internet because port 80 has been blocked on the firewall. So firewalls can block traffic and allow traffic. You can allow any rules to access, to allow everything to go through it. Not recommended, but that's essentially what a firewall does, right? So you've got physical firewalls, things like a Cisco ASA. You've got things like software firewalls as well, like Microsoft Threat Management software as well. Something like what's another good firewall? pfSense, which is a free open source firewall, which is super cool. That is another example of a firewall. So load balancers as well. Again, these can be physical or virtual. Virtual, when I say virtual, I'm talking about, let's say, a virtual server and it's got software running onto it. So physical or software based, right? Hardware or software based. So your load balancer's job is essentially, as the name suggests, is to balance the load. So you would use a load balancer, for example, for a website. If you've got a website that has a lot of traffic going through it, there's hundreds and hundreds, even thousands and thousands of incoming requests to that website, you can potentially destroy your server that's sitting on it. You've got one little server accessing, all this information and presenting it to all of these people out on the World Wide Web trying to access it all at the same time. What you can do is with load balancers, you can have multiple servers. And the load balancer's job is, okay, well this traffic coming in, it hits the load balancer and let's go to server 1. Hits it, well the second one now goes to server 2. A third person tries to access the website, it goes to server 3. So it actually essentially load balances your load so that you've got more, less load on your servers, essentially is what it's going to do. So that is a load balancer. So physical hardware will be something like an F5, super cool load balancers. You've also got things like HA proxy, which is running on the software front as well. Again, it's free. HA proxy, very cool software to check out for load balancers. Okay, there are other bits and pieces on the network. All right, you've got gateways, you've got proxies, that sort of stuff as well. But let's just move away now from the network, I guess, infrastructure, and let's move into the server infrastructure. So there's a whole bunch of stuff on the server infrastructure that is available as well. You will have physical servers, virtual servers as well. All right. Physical servers are you've got a computer at home. You could have a laptop or a desktop. These are potentially computers, right, that can act as servers. You can actually make a laptop into a server if you really want to. You can install the server software onto it, but it may not run very good. It may not be able to process all of the power that it needs to be able to give all the requests out to your business. So what you would do is you would have larger scale servers. So you may have seen these huge servers. They're rack servers. You can get blade servers, which are different dimensions, different configurations, different options like that. A lot of companies make servers. You've got Dell makes some really cool servers. HP makes some servers. And these are servers that you can rack into your infrastructure, right? So you would have your big infrastructure set up, your cabinet set up, and that would rack into that, all right? Then you can then go ahead and install your operating systems directly onto your server. So something like Windows Server 2012 R2, which is a software package by Microsoft for the server environment, would load onto this server, and then you've essentially got a server that is beefed full of RAM, huge amounts of RAM, heaps of CPUs and processors and cores and that sort of thing. So you can actually have a very powerful computer that can go and offer its services out to the company. All right. What a lot of companies are now doing is they've got what's called they name their servers hosts, and you can run what's called hypervisors onto your physical servers. So they are becoming hypervisor hosts, and then you can potentially run multiple virtual servers on top of your physical server, right? So in the olden days, you would have to have, let's go physical server 1, that's my file server. Physical server 2, that's a database server. Physical server 3, that's a web server, right? Now you can have just one super beefy host. You can run something what's called a hypervisor on it, and then you can run the file server, the database server, and the web server all virtually on the one physical server. right? Which is a very cool technology. It's a lot cheaper in the long run because you are, well, you're not paying for as much electricity, you're not paying for the rack space in a data center, for example. So that is the way to go. It's a lot easier to manage, right? So the big contenders are things like VMware. You've got the ESX, you can add what's called an ESXi host into this virtual software. Citrix does it, Microsoft does it as well with their Hyper-V. Oracle has their own one as well. So there's a lot of different options out there for virtualizing your servers, but that is generally the way to go. You can then go even more upscale and look at blade sort of chassis and things like Cisco UCS and things like that. But you know, a lot of guys do tend to go for like the PowerEdge, the Dell PowerEdge server infrastructure for their physical servers. The next thing is storage. So again, if we're using the scenario of you at home, you've got a computer at home with, I don't know, 2 terabyte hard drive built into it, all right? And you think, cool, that's heaps of storage, that's heaps of storage. Imagine if I have a server with 2 terabytes of storage and I've got 200 staff and they all want to store their stuff on this file server. That's going to fill up very, very quickly. You can get a server with a whole heap of hard drives in it, right? And essentially have 20 terabytes worth of storage. And that may do the job for a time being, right? You can set up these things called RAIDs and that sort of thing. We won't go through that today, but that is an option. What a lot of guys do is they have what's called a SAN or a NAS. So a SAN is a storage area network or a network attached storage for a NAS. Essentially what these SAN and NASs are is they're just huge cabinets. They don't have to be huge, they can be smaller. And they're just essentially, let's call them servers, racked full of disks. All right? So you'll have one processor, let's call it a storage processor down the bottom. That's all the brains of it. It just contains all of the data, all of the brains, to all the processing power, the CPU, the RAM, everything's on this little storage processor. And then above it, you've just got disk arrays, just full of disks, right? And they're all bundled together into what's called a SAN or a NAS. So you can then go ahead and share this storage. If you've got things like what we were talking about before, virtual servers, you can share parts of the SAN storage on your network. You can share this. You can add it as a file share. You can share it on a VMware environment as what's called a LUN on the storage front. So SANs are super cool. Heaps of companies use them for their massive amounts of data. So even the huge companies, I mean, if you're talking about the likes of Google, those sort of guys, they've got, I don't even know what they've got, but they've got petabytes and petabytes and petabytes, maybe even zettabytes worth of storage on them, which is just essentially made of just racks worth of just disks and disks and disks. So that is the storage. So you connect the storage via what's called HBAs generally, say via fiber channel or iSCSI, things like that, and they're super cool. So we mentioned HBAs before. So on the back of a lot of servers nowadays and on the back of storage units, you've got what's called HBAs. So similar to a network card, which traffic goes through your network, right? Your TCP/IP stack. HBAs can pass other traffic. So things like fiber channel, you can pass iSCSI commands, those sort of things as well. So your HBAs are generally, if we're talking about on the storage front and on the host front, on the server host front, if you want to connect these two together, you can connect them via the network to get access to the network, but they also need a connector to traffic all of your storage traffic, right? So these are what's called HBAs. So they're going to be the physical cards on the back of your devices, allowing things like fiber channels. If we use fiber channels, for example, which is a technology which is super quick, you got up to 16 gigabits. There could be 32 right now, I'm not sure. And you can just pass the traffic super quick through your network, not via Ethernet, right? You're not going via those network cables, you're going now via fiber channel instead. And that is the HBAs, which will be on the back of most of those devices as well. Then you got your backup infrastructure, all right? You've got things like, you've got physical servers for backup, you've got tape libraries as well. A lot of companies nowadays are using disk backup things, right? Which could essentially is like a SAN. So the SANs have got things like EMC, are the brands, NetApp. You've got Isilon for making a SAN and a NAS. On the tape front, you've got things like Dell, you've got Spectralogic making huge scale tape libraries. But yeah, as I said, for backups, you can back up to disk, you can also back up to tape as well. Tapes are always handy because when you back up, let's say you've got 200 servers, you back them up every night, they can go onto tapes, and then these tapes go off-site somewhere. So in the worst case scenario, your data center or your company burns down, you've got all your tapes backed up somewhere off-site. So you can go and rebuild your stuff, bring those tapes back, and then restore all of your data. So that is your storage tape infrastructure there. Then you've got things like your telephony as well, something like your PABX, your switch ports, you know, like your what do you call them? Your Chrome switch ports to have your traffic coming in and out for your phone lines. You have your PABX, you've got your big end companies that have their servers for all of your phones, for your VoIP, that sort of stuff. So your PABX essentially is your big phone system, all right? So all of your storage, your servers, your networking gear, your PABX, all that sort of stuff, generally in a company you'll have what's called a data center. So a data center or a comms cabinet or something like this is a place where all of your stuff lives, all right? A lot of companies, a lot of smaller companies especially, will have these on site, which is just easy, it's ease of use, it's cheaper, that sort of stuff. Bigger end companies may have dedicated data centers off site, or you could be renting a particular space in a data center, right? So there's a lot of companies that just specialize in just renting out their equipment, their racks, their cabinets, and you pay a premium, you pay for their electricity, for the usage, for the rack space, all that sort of stuff. You pay them, and then they essentially just host your infrastructure. You as a company, you as an IT administrator, for example, we're still managing it, but they're the ones who house it for you. And then you'd have all your links coming from your data centers, which could be off-site somewhere, or your links running into your office, which could be somewhere else. Could be on the other side of town, for example. So all of these data centers would just house all your infrastructure. You could have them indoors in your own office space as well, but you're going to be essentially racking all of this equipment inside there, right? You can have multiple cabinets racking between them. The cabinets themselves will have what's called cross connects as well, similar to patch panels, that you can run cross connects between the cabinets, fiber and Ethernet cross connects, for example, where you've got one here, one here, one here. So rather than I've got a server on this cabinet and I want to run it into a server on this cabinet or a switch on this side, I don't have to run a cable through it and go via a cross connect, which goes through the back and into the cross connect here and then down into my switch, for example. All right. So if we're looking at an overhaul, that is the general overview of the physical hardware for a company, for an enterprise, for a large scale, even a small scale company will have this general infrastructure. There is other stuff which we haven't talked about in this, but that is the general core of the hardware. On top of that, you've got a whole heap of software stuff that's running in the background as well. So we're not going to go into too much detail, but all of these servers and all this sort of stuff needs to have things running onto it. So you've got things like domain controllers, you've got DNS, right, which lets you give IPs to your host names. You've got things like DCP that gives the IPs out to your computers. You've got, what else do we have? We've got, you've got things like vCenter, which is your virtual infrastructure for managing your VMware infrastructure. You've got NTP for managing the time. You've got, you know, antivirus servers that manages all your antivirus. You've got management servers, things like SCCM, WSUS for patching. There's just a whole range of stuff, software-based applications that manage your fleet, help you manage it better, gives you alerts, keeps it up to date, all that sort of stuff. So I hope you found this helpful. I mean, that is a general overview. Feel free to comment and ask me any questions that you want. I'm always helpful and ready to help if you need to. So give us a thumbs up if you did find this helpful, and subscribe to Digital by Computing for a whole bunch of more videos.